Tim, as far as language and these systems, they're really like UFOs. You hear about them, you never see them. Every time I try one of them, it doesn't know. I don't want to be, it's too early to speak French. There's no, we keep saying they're doing well. Where? Come on.
Walid Saba is a polymath, a neuroscientist, a psychologist, a linguist, a philosopher, a statistician, and a logician. One of the arguments that he makes vociferously online is that natural language processing is not the same as natural language understanding.
I lived the transition from the GoFi, the good old-fashioned AI, into empirical AI.
You should definitely check out Walid Saba's Medium page. I've taken the time to read all of it. It's an absolutely fantastic collection of information. And the first one to look at is his most recent article, which is Time to Put an End to BERTology. He believes that machine learning is not relevant to natural language understanding. And in here, he makes three core arguments. So the first one is this missing text phenomenon. And he thinks that most of the time when we communicate, we're extremely ambiguous. And the important information is simply not in the data. If you ask any deep learning practitioners, what do you think are the core challenges in deep learning? They will answer you, 1. Sample efficiency problem. 2. The generalization problem. According to Walid Saba, he thinks the missing information problem is the biggest one.
There are 10 big problems in language. Computational linguists give them labels like metonymy, lexical ambiguity, metaphor, all these big problems in language. And they're all a manifestation of the missing text.
So he gives an example of the missing information problem here. Xanadu quit graduate school to join a software company. We have an ontological structure in our brains. We can fill in the gaps. So we can create data where none was transmitted. So we know that Xanadu is a living young human adult and was in graduate school, but quit graduate school to join a software company that had a need for a new employee. So we filled in a lot of information there. And Walid gives many examples. These are the biggest domains in natural language understanding where there is pervasive missing information, and humans can fill in the missing information because we have that ontological structure in our brains. Walid then provides what he believes is a proof that machine learning cannot perform natural language understanding. He says that machine learning is equivalent to compression, that natural language understanding is not compression, it's expansion, and therefore natural language understanding is not machine learning.
What we have that's missing are not rules. Ironically, they are data, but different kinds of data. It's the data we don't say. So it's like data plus data will do the trick.
He also talks about this concept of intention, spelt with an S. Now, this is really important in logic because most of us programmers and people that have done empirical science, we think that two things are equal only if they share the same value. But intention means that they are equal if they share all of the same properties. So there are some examples here of some mathematical constructions which have the same output, but clearly the properties or the construction is different. So logically, these things are different, which means they have a different intention. They have the same extension, but they have a different intention. And in natural language understanding, there are almost 0 degrees of freedom. The intention is very important. And this is something that Walid points out a lot in many of his examples. So, for example, Mary taught her little brother that 7 plus 9 equals 16, and also 7 plus 9 equals the square root of 256. Those two are different. It also points out there are many examples in natural language where statistics don't work because words appear with equal probabilities. A great example of that would be scope resolution or pronoun disambiguation. This one, for example, the trophy did not fit in the suitcase because it was too big or small. What does the it refer to, and was it small or big? So Walid points out that the autonyms or opposites such as small and big, open and close, occur in the same context with equal probability, so it's impossible to statistically infer which one is correct. But yeah, I highly recommend you check out Walid's blog. He's got some incredible stuff there, also talking about the concept of memorizing versus understanding, and talking about how, in his opinion, the tech giants are hampering progress in cognitive computing. Learning from data and observations are underrated. Word embeddings, the good, the bad, and the ugly. And there's some stuff about his company, Ontologic. It's really good, so make sure you check this out. So back in the days of expert systems, there was this concept of the knowledge bottleneck. it just became incredibly onerous to capture this knowledge because you needed highly specialized engineers and there was just always more knowledge to capture. So one of the main reasons behind the empirical data-driven revolution that took the AI world by storm in the early 1990s was the supposed brittleness of the symbolic or the logical systems, the never-ending need for more carefully crafted rules. The paradigm changed to machine learning in the late 1980s, and the idea was that the algorithm could somewhat discover these rules automatically by approximating a probability distribution function. Ironically, though, data scientists now are wasting more time than ever, probably spending about 80% of their time just crunching data. So did we overreact to the knowledge bottleneck in the 1980s? Tacit knowledge is normally implicit inside the expert's head. It needs to be externalized and made explicit. So this is what led to what's called the knowledge bottleneck. It's one of the key issues in knowledge engineering. It was said that machine learning would help us overcome this bottleneck, but Walid said he hasn't seen any sign of that yet. Ambiguity in language is a necessary mechanism to ensure effective communication of thoughts through language. If things seem ambiguous, it's because they are highly compressed and the listener has the necessary common knowledge to decode what's being said. We don't transmit any redundant information. This should actually be reassuring. Perhaps this is an emergent, convergent phenomenon in humans. Walid thinks that this entails that our common data repository can't be learned. Otherwise, it wouldn't be common. He says that different experiences would lead to different knowledge.
There's a lot of information we don't convey because I assume you have it. We call it the common background knowledge. The test should be, can you uncover that information? Then you're doing understanding. So if I want to follow Shannon's efficiency for communication, I leave it out because I know the receiver has that information. The language understanding problem, the U, and that makes it different from the NLP, is finding that stuff that we take for granted because I know you know it. But obviously, we don't stop each other on every time we're talking and say, hey, wait a minute, what do you mean by that? What do you mean by that? We don't. We understand each other very nicely. We understand each other. Language is ambiguous in the sense that we compress things and then we try to uncompress them until the picture is clear. But if I say Java just told me blah, 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 Java is a human. Islands don't say anything.
Walid thinks that language cannot be learned.
There's no time to learn language. It can't be learned. My God, a 4-year-old can barely walk, but they can speak fluently. The structure they have is much simpler than we think. Look at the word. We disagree on very few things. The way the word works physically, logically, chemically is not up to you or to me. There's an agreement. Otherwise, you're called stupid or doesn't know science. There's very little disagreement in the world we live in. There are facts in this world, and these facts are undisputable. That means they're not learnable. They're not susceptible to data.
Walid also believes that language is a formal language. It's not something we figure out. We have an internal compiler. It works according to rules. We just haven't agreed on or figured out what those rules are yet.
Language is a formal language. It's just that we haven't figured out the compiler of that damn language, right? There's a compiler for natural language in our head that compiles natural language, type checking and all. It does everything according to rules we agreed on, obviously, but we haven't figured it out.
Chomsky and Norvig came to blows recently, and the argument was fundamentally over whether we should be learning from data or whether we should seek to understand, whether it would be possible for us to build a model of understanding for intelligence itself. Norvig was one of the AI pioneers, one of the old school. He really tried to figure this out the old-fashioned way back in the days of expert systems. He spent decades on it, he was lavishly funded, and ultimately he failed. And now he's working for Google. Now he has the mindset that we should use the petabyte storage clouds and we should memorize and interpolate between everything on the internet.
Technically, theoretically, deep learning could figure all of this out if given enough data.
Learning from data has a ceiling. It's the intelligence of animals because they do pattern recognition actually better than the best neural network that is out there. An eagle sees from 2 miles away. If you can get to a point where you can differentiate between a mall and a university campus, the information you need to realize this is not a This is not a campus. This is a mall. It's not in the data.
I watched a presentation that Walid did a few years ago, and he's always been quite clear with the messaging that a lot of ontological information is not in the pixels, it's not in the data, it's not in the text. And he gave this example in his presentation, and he said, would a vision algorithm ever know that this is a teacher and a student? And in this case, would the algorithm know that it's a mother, a daughter, a family, a husband, a wife, and so on? So I've just put it into the Azure Vision API, and this doesn't look terribly good, actually. It's got posing person, photo, girl, woman, smiling, young, group, people, man, holding. That's not terribly good, to be honest. So this is the Google Vision API, and here we've got person. Now the gender has been removed from this. We have leisure, child, family, pictures, family taking photos together. So semantically, this seems much richer. So interestingly, we can extract that kind of semantic information. When I drag in the teacher-student one here, this is really good. So learning, 95%, education, 94%, class, 92%, student, classroom. It's done incredibly well, actually. It really can tell that this is an educational setting. And if you wrote some code here enumerating this information, you would be able to tell that the relationship between this woman and this child here is that she's a teacher rather than her mother. Walid would point out, though, that deep learning here has just given us basic information. It has not given us knowledge.
That's not in the data itself. If everything is in the data, then actually we would have a completely different science. There are models inside. There are models like force is mass times acceleration. Okay, you can try it on few examples and you say, oh, it works. F is m times a on few observations. But until you figure out that for all, it's not about these few examples that I tried. You don't have a model. What the problem with the empirical methods is, they are religious about symbols and admitting there are symbolic structures. Let's call them whatever you want. They don't want to admit one symbol in the system. I can learn everything. Yann lecun had a paper, which I'm sure he's ashamed of now. He put on the archive that you can learn language from characters all the way up. Come on, man. Come on. Immanuel Kant was not stupid. You're not smarter than him. There's a limit to how far you can go with your extremism. They don't want to admit one symbol. It's all neural firing. They have the inside of the brain in their sleep. Like it's all firing. And wait a minute. Who told? If that was the case, the difference between our brain and the chimpanzee is what? Is negligible. Yet a chimpanzee will take 2 more million years and they will not speak. So there's something else besides the firing, my friend. Animal intelligence have been studied a long time ago. The best they can do is association. They cannot do the experiment with the monkey. They put a box that if they stepped on it, they would reach the banana. But they put the box in the corner of the room. The monkey almost went hungry. They didn't do one simple deduction. I need that much height. That has that height, if then else. The difference between us and animals, you actually made my point. We're almost identical biologically. So there's something else, obviously, right? And if you think about it, it's language and thinking. And that was discovered years ago. Thought and language are if and only if you can have thought. So language is not just NLP.
There has been a perpetual war about how to characterize machine intelligence. Connor Leahy on last week's episode asserted that he thought it was an open problem whether humans are even intelligent or not.
It has to be psychologically plausible, cognitively plausible, and computationally plausible. Otherwise, something is wrong, right? So if you have zero knowledge and you're trying just to look for a needle in a haystack, you probably could find it, right? But then it's the theory of computation here kicks in, and it's if you give me an infinite amount of time and an infinite amount of memory, right, I can compute anything. Yes, but I think what we call intelligence is about not needing that infinite amount of time. It's not accidental that Alan Turing thought of language as the test for intelligence. He didn't choose pattern recognition. He didn't even choose game playing. I mentioned that in my post because games, as big as they are, they're finite. So if you give me enough compute power, I'll screw you because I'll compute every possibility and I'll have a score for every path, you're dead.
15 years ago, you had to have specialized knowledge about vision or language processing. You actually needed to know something about the subdomain. The famous NLP researcher, Yoav Goldberg, he said something quite similar. He teaches a semester on NLP, and he said that it's very depressing at the moment. He doesn't know how to do it, where he's torn between two perspectives. So one, teaching the interesting problems, why language is interesting and why language is hard, how language is structured. The problem there is that he'll mostly be presenting a set of open questions without any good solutions to any of them. We suck at absolutely everything. He goes on to say, on the other hand, we could talk about the deep learning perspective. We can teach embeddings and BERT and fine-tuning and squad. These techniques work quite well, but we don't really know why. They fail a lot, and we've got no idea how to improve. The problem with this connectionist Tabarrossa deep learning paradigm is that it's so far removed from any technical knowledge about natural language processing. Even AI pioneers like Marvin Minsky and John McCarthy were humble enough to only claim authority on one or two subjects in artificial intelligence. Whereas now, all you need to know is how to build neural networks. You don't need to understand anything at all.
Yeah.
But is that the good or the bad?
It used to be that in data analysis, we thought that garbage in was garbage out. And all that deep learning has changed is that garbage in is garbage out with a high degree of confidence. It's
garbage
like,
in, papers out.
Yeah, it's like you have people that they don't know anything, and they could write a bunch of code. And there's this sort of mathematical passport type psychology that goes around where if it's complicated enough and I put enough math in there, even if it's just trash.
When Vaswani introduced this new language model that predicts the next word, you don't need to know anything about language whatsoever. You're just producing the most general blank slate deep learning model to predict the next word.
But I work in the field. I was around ML people, which now means NLP. Like, wait a minute, NLP is not ML, and NLU is not NLP, and it's not ML. Those young kids who put on their LinkedIn ML dash NLP dash AI dash DL dash Internet of, they have no idea what language is. You know what language for them is? Tokenizing, stemming, it's text.
Yeah. In your article here, you actually have some technical descriptions of concepts in language, like this one, metonymy.
Right.
If you ask anyone who's got NLP deep learning on their LinkedIn profile what that means, no one's going to know the answer, are they?
Forget it.
We spend a little bit of time talking about deep learning and Walid's opinion on deep learning.
I am not a critic of deep learning per se, not at all. Actually, in so many problems, not only is it a good technology, it's the only technology.
Walid thinks that some functions can be solved with neural networks, and those relate to a very small class of problems where the solution can be approximated by processing massive amounts of data and finding correlations and memorization, especially when there are a finite number of solutions like Go or chess, for example.
Now, you really have people that believe a 10-line algorithm, backpropagation, and the gradient descent method explains the mind. That has to be on its own. Before I dig into the details, on its own, that's gotta be ridiculous. We do all kinds of reasoning. Statistical reasoning is one of them. We do default reasoning. We do analogical reasoning. Our mind cannot be explained by Bayes' theorem and backpropagation. Things I can teach in half an hour. Please, and all those philosophers and all those brilliant logicians that worked for centuries on this problem cannot be idiots. You, Mr. Young guy who just took 2 courses and you know TensorFlow and PyTorch, they're not idiots. Maybe you are. I have a friend of mine, his son is, I'm that old, his son wants to do grad studies in AI, and he said he couldn't find an advisor that would take him because he doesn't want to do deep learning. He loves deep learning, actually, he toys with it, but he wants to do AI with a different paradigm, and he can't because all the funding, all the conferences, they're all Google, they're all Facebook. If you don't do deep learning, screw you. And now even in government funding, if your research doesn't have deep learning every other word, no money. So that's not good.
We speak about the potentially flawed ways in which we evaluate natural language processing models.
It's never in a novel. It's like, and Frank entered the door. And then Mary said to Frank, what did the in the last sentence of this very novel refer to? That never happened. So if I enter the corner table wants a beer, and then I ask it to continue the text, and the next sentence is, all right, let's get the guy one, or all right, let's get the couple another set of glasses, then to me, that means the neural network understands that there is a person. Whether or not internally does this whole logic reasoning is a different question.
You have an innate ontological structure. The entire ontology is like 2,000 types. Something you can code in one day.
The nearest term to an ontological concept is what logicians and mathematicians have for centuries called natural kinds. These are concepts which just exist. Humans didn't make them. These concepts are not defined with conditions or criteria. They just are.
We actually do type checking. And when the types have a mismatch, we do type unification. And that's how we discover the missing text. There is a way to uncover what you didn't say. Like the corner table wants another beer. Want and wants a beer expects a human. You found a table. So you do unification and you figure out what is the salient relationship between person and table, and you discover what is meant is the person sitting at the table wanted. So there are types that are in your type checking. Basically, your type checking in language, it's like a formal language to me, is about saying, let me make sense out of what was said. And after you try to make sense out of what was said, you discover the stuff that wasn't said. That's what goes into the mind, and the mind applies now the innate knowledge, that ontological structure. That information cannot all be numeric. This comes to the intentionality we can do with intention. So obviously we pass richer structures than that. Now, if you combine that with the learnability, the power of the neural net is the learnability. If you combine learnability with richer structures, man, you're onto something. But you want to fix it on vectors and numbers? I don't believe that information is in the data itself. There's another structure that powers and constrains these degrees of freedom that are all over the place. There's a constraining system inside. Kids show us this.
So Jane was wearing a beautiful red dress, and no one would ever say a red, beautiful dress.
So there's a lot of evidence that tells us there's something that constrains all these possibilities.
Walid believes that knowledge graphs don't actually contain knowledge. They contain structured information, usually in triples, so entity, relation, entity. So looking at Walid's information hierarchy, going from data through information and knowledge, Walid asserts that we start from signals, so being able to make very basic type judgments, and data is just uninterpreted signals and strings and literals. And then we move to the next level of the hierarchy, which is information. So information is a meaningful organization of data. We can say things about all instances of a type using these typed functions. So humans articulate, humans make artifacts. An event is imminent. The most enriched level of information or data is knowledge. Knowledge is when we can create functional and typed constraints over data. There's so much ambiguity in information, and what we need is a very rich ontology or a kind of type system so that we can constrain all of the possibilities. So there's a great example here that Olga is an agent and she's attractive. A knowledge base is basically just data. It's just structured data. So here we have some personnel information and whether or not they have children. So for example, Elvis Presley has a child, Lisa Marie Presley. So far, this is just a structured database. But what we can do is we can add structured knowledge. So we can say, what does it mean to be a daughter between two entities? If the entity Y is a child of entity X, and if the gender of X is a female, then we know that means it's a daughter of X. And we can do the same thing with son. So now if we ask the question, does Elvis have any sons? We can enumerate the children of Elvis, and we can check that the gender is male. So we can go to Google and we can say, how many children did Elvis have? And it says 1. Children, Lisa Marie Presley. So then I say, how many sons did Elvis have? It says 1, but that information is incorrect. And if we could have this rich conception of knowledge that we've just shown here, we would be able to infer that Elvis did not have any sons.
Many people said to understand human communication, we have to reverse engineer language itself. The final representation has to be language agnostic, otherwise you're doing something wrong.
Technically, Walid is not a symbolic person either.
You have to reduce it all to internal stuff that we all have. Otherwise, you're doing symbolic stuff. So that's why the symbolic camp also doesn't like what I'm doing. So I'm stuck in between.
Now, we had some great comments on the last video that we did with Connor Leahy, and one particularly good comment was from Vidrak. And Vidrak wanted to hit in on our claim that these statistical language models are just memorizing everything on the internet. So on Yannic's original video on GPT-3, he basically said that it's very clever interpolation, it's memorizing things to some extent. Vidrak pointed out that there are several places in the video where he said something along the lines of, I would be impressed if it could do this, where actually it turned out to do exactly that. So if we come down into the examples that Vidrak gives later on here. So Gwern is a very interesting character. I've been following him on and off for about 15 years, I think. And he references this database prompt, which was an experiment by Matt Brockman. Let's read this out. The database begins knowing nothing. The database knows everything that's added to it. The database does not know anything else. When asked a question, if the answer has been added to the database says the answer. When asked a question, if the answer has not been added, the database says it does not know. So this is insane. We've just described a computer program using natural language. Question: does the database know what is 2 plus 2? Answer: the database does not know. Question: does the database know what is the capital of France? The database does not know. Tom is 20 years old is added to the database. Question: does the database know where Tom lives? Answer: the database does not know. Question: how does the database respond to Tom's age? The database says Tom is 20 years old. Question: how does the database respond when asked what is my age? The database says you are not in the database. This is absolutely fascinating. It's almost as if we've constructed a computer program using natural language, and GPT-3 seems to be performing some kind of reasoning beyond which you would expect from interpolation. It clearly opens up a new paradigm of application development, and also it makes us redefine our conception of intelligence. So Vidrak also cites this online fitness AI knowledge beta. Now this is actually hooked up to GPT-3, so you can query GPT-3 if you formulate your question to look like a fitness question. So here we can paste in Vidrak's example, which is written in Python code. So there's an array here, fitness, health and heart. In B, there's another array which is lifting, curls and squats, and C is running and jogging. And then the prompt is, so what is b.append pushup? So it's asking a Python programming question in natural language. So we go ahead and we run this, and it gives the answer. It says the answer of b.append pushups is lifting, curls, squats and pushups. So it's understood what is B and what would happen if we appended push-ups to B, and it's given us the answer in valid Python code. This is just unreal. The other thing Vidrak points out is in the original GPT-3 paper, they said that it doesn't really do addition when there are many digits, but this might be explained by the byte pair encoding problem. For efficiency and to reduce the number of tokens going into GPT-3, it does byte pair encoding. What that means is that if tokens appear frequently together, they get atomized into one token. So you can see here that this person is going through all the different 3-digit numbers and showing you whether they are one token or whether they are 2 tokens. And there's a fairly strong possibility that this is the reason why GPT-3 couldn't do addition to many digits. It had nothing to do with it memorizing particular combinations on the internet and everything to do with this coding. So if you put commas in, so you circumvent the byte encoding, then GPT-3 can do addition up to about 9 or 10 digits reasonably reliably. And that does seem to imply that it is actually doing a level of generalization beyond which we thought before. Vidrak also points out this interesting example here, which is the letters in jogging are Jogging. Now notice that spaces between the letters there are to avoid the byte pair encoding problem. And scrambled, they are GOJGNIG. What are the letters squatting and what are they scrambled? And then the answer is, note, the letters in squatting are squatting, and scrambled, they are TINGSQUA. Now, that's actually missing one of the letters, but this is incredible. What we've done is we've described an algorithm in natural language, and we've just one-shotted it, and GPT-3 knows what we want to do. This is absolutely mind-blowing to me. So I have to update my position a little bit here. Before, I thought that GPT-3 was just memorizing and interpolating between examples on the internet. What we're seeing here is an example of one-shotting or few-shotting and being able to perform fairly sophisticated tasks. It may not be reasoning. Maybe it's still just looking at some kind of statistical patterns in the data that would be impossible for us to understand. But it's now learned this representation that is so sophisticated that it can do things which appear like intelligence to us. It does make us redefine our conception of intelligence. Another thing that happened recently is Yann has come out there and criticized GPT-3. He says that some people have completely unrealistic expectations about what large-scale language models like GPT-3 can do. So he says that GPT-3 is a language model, which means that when you feed it text and ask it to predict the continuation of the text one word at a time, GPT-3 doesn't have any knowledge of how the world actually works. It only appears to have some level of background knowledge to the extent that this knowledge is present in the statistics of text. But this knowledge is very shallow and disconnected from the underlying reality. Yann is basically agreeing with Walid Saba saying here today that we do have a rich, common, ontological knowledge store in our minds, and this tells us about how the world works. And we need to have this common knowledge store in order to unpack the information that we receive via language. So this article also blew up on Hacker News. Some of the comments here are talking about the philosophical question of whether knowledge and language are the same thing or whether knowledge is separate. Clearly, Walid Saba believes that knowledge is separate, that we have an innate hierarchy of types or natural kinds in our minds that are baked into us or bootstrapped pretty much soon after we are born. And this allows us to decode or unpack the information transmitted in language. Language is very ambiguous, and without this unpacking or knowledge representation that we have in our minds, we wouldn't be able to make sense of anything. So Lefty Ted said, I think this is a philosophical question. There is a view that basically there's no such thing as knowledge, just language, or at least there is no distinction between knowledge and language. In this view, all there really is language, which is mostly composed of metaphors, and ultimately metaphors only refer to other metaphors. Language is circular. In this view, not only is the ultimate physical concrete world beyond us, but we also can't even talk about it. From this perspective, GPT-3 is not substantially different from what our minds are doing. The same person also made a comment later on invoking George Lakoff. Now, Walid Saba invoked George Lakoff towards the end of our presentation today. We, in English, use war metaphors to talk about arguments. Of arguments and of wars, you can say things like he's marshalling his forces, they're ceding their territory, or she's girding her defences. In fact, almost anything you can say about a war, you can also say about an argument. In American politics, with regard to partisan squabbling and filibuster, we talk about the nuclear option. The fact that these metaphors make sense to us indicates a judgment, something like arguments are like wars. That judgment shows up in billions of lines of English scraped from the internet and can be fed into a model, allowing GPT-3 to make that connection via purely statistical methods. Yes, this is a bit like asking what a library believes, but a lot of these metaphors shows up in our language, and by the way, they express judgments, which is something akin to a belief. Does that mean a library has beliefs? Is this all knowledge is? I wouldn't go that far, but the argument is an interesting one and worth raising. Very interesting. So there was a paper just released in Minds and Machines called GPT-3, Its Nature, Scope, Limits and Consequences by Luciano Floridi et al. He says in the abstract that this is a reminder that GPT-3 does not do what it is not supposed to do, and that any interpretation of GPT-3 as the beginning of the emergence of a general form of artificial intelligence is merely uninformed science fiction. So Luciano talks about this concept of irreversibility, which is very similar to Walid's concept of the missing text, or also the ambiguity in language. Who mowed the lawn? Ambrogio, who is a robotic lawnmower, or Alice? We know that the two are different in everything: bodily, cognitively in terms of their information processing qualities and behaviorally in terms of their external actions. Yet it is impossible to infer with full certainty from the mowed lawn to who mowed it. So irreversibility and reversibility are not a new idea. In our brains, we know that people mow lawns. We also know ontologically that robotic lawnmowers mow lawns. So it's impossible for us to infer in this situation which entity mowed the lawn. It's completely ambiguous. But this concept of reversibility is really interesting. So one of the experiments that Luciano did here was asking GPT-3, tell me how many feet fit in a shoe. GPT-3 gives a nonsensical answer. I don't know, said the boy. How many? Just a load of nonsense. Walid Saba would argue that GPT-3 doesn't understand because it doesn't have the rich ontological structure in our mind that can allow us to fill in the missing gaps in that information. Anyway, I hope you enjoyed the episode today. Remember to like, comment and subscribe. We love reading your comments. Next week we have an incredibly exciting guest. Frankly, I don't know how the hell we managed to pull this off, but it's actually happening. So tune in next week for a surprise guest. Cheers.
I think we're in 3 time zones.
So we've got New York, you're in California, right? And then I'm in London and Yannic's in Switzerland.
So it's 4. Yeah.
So welcome back to the Machine Learning Street Talk YouTube channel with me, Tim Scarfe, my 2 compadres, Yannic Lightspeed Kilcher, Keith Bayesian MIT PhD Duggar. And today we have a very special guest, Walid Saba. Now, Walid is an expert in natural language understanding, ontology, knowledge engineering, conversational AI, and personalized recommendations. He's quite prolific on LinkedIn, actually. I discovered him on LinkedIn. He's got a huge loyal following, and he makes some really insightful posts and lots of entertaining commentary. So that was how I discovered Walid. He's also got a blog on Medium where he talks about his views on natural language understanding. And to summarize his views a little bit, he thinks that it's time that we put an end to BERTology. BERTology is the name that Walid uses to describe the current kind of deep learning or statistical approaches to natural language processing. He thinks that natural language understanding is not the same thing as natural language processing. He cites the missing text phenomenon. So many of our utterances in our language are compressed. We leave out crucial information. There's an example that he cites, the corner table wants a beer. Well, actually, we're referring to the person at the corner table wants a beer. And these words are never spoken. So statistical models would never find out that we're talking about a person. And he says that this is the same across all languages, not just a thing in English. So he says that there are many instances in language where statistics will not allow us to resolve the meaning. He also talks about this really interesting concept from the logic world, which is intension versus extension, which means that language actually has almost no degrees of freedom. And I'm sure we'll get into that shortly. He also thinks that word embeddings, and of course we all know about word embeddings, he thinks that they're just not fit for purpose for describing language because they only have a very one-dimensional relation to each other. He's advocating that we should have a rich typing system capturing the ontological structure in language. Anyway, a bit about Walid's career. He's the co-founder and principal scientist at Ontologic, which is a company that has been around for about a year or so. He was a principal AI scientist at Astound for 3 years. He was the co-founder and CTO at Klangu for 6.5 years. And he's also held many other impressive positions in companies. He's got a very long, illustrious career, but he was also the associate professor at the American University of Technology, at the American University of Beirut. He was an assistant professor at the University of Windsor. So that was a period spanning about 7 years or so. And he's got a PhD in computer science from Carleton University, and also a bachelor's and a master's in computer science from the University of Windsor. Walid, it's an absolute honor to have you on the show. Thank you so much for joining us.
Oh my God, it's my privilege, my honor. I thank you for actually inviting me, and I hope I will have something useful to say. As you can tell, I am very passionate about AI. For me, AI is my kids. All my life, I've thought about my kids and AI, sometimes one more than the other. I'm not going to say which. So I've lived with AI for 30 years before it was a cool subject. And I lived through the AI winter, believe it or not, where I took everything called AI from my CV and I sold myself as a software engineer. After all, I'm a computer scientist. And I lived the transition from the GoFi, the good old-fashioned AI, into empirical AI. Let's call it empirical, as opposed to BERTology for now, where things started to go statistical NLP. You mentioned word embeddings. There was Gary Salton, who was a pioneer in the text retrieval, information retrieval world. It was a big thing back then, document retrieval, where he came up with the vector model for representing documents with vectors and then do the cosine similarity, and that was the measure of similarity. We're talking in the 60s, right? So the idea is not entirely new. It's like deep learning is not entirely new. They are more powerful neural networks. We have a lot more computing power, but same paradigm, backpropagation, and you optimize through stochastic gradient descent. The model is essentially the same. And the idea of representing content with vectors, believe me, before the end of the 60s. That's how old it is. So there's nothing new under the sun, really, if you think about it. Okay, I'm probably exaggerating a bit, but not much, believe me. So I've lived in this world for many years. I'm an interdisciplinary sort of guy. I go to neuroscience, psychology, linguistics, philosophy, statistics, logic. So I don't like it when I see extremism. Now, you really have people that believe a 10-line algorithm, backpropagation, and the gradient descent method explains the mind. That has to be on its own. Before I dig into the details, on its own, that's gotta be ridiculous. The problem is the runaway train is going so wild that nobody would listen. I have colleagues of mine, very respectable people that I met at Bell Labs or IBM Watson in my other life. And I chat with them and I say, hey, Vlodek, what the hell's going on, man? What happened to AI? He said, don't talk to me. I don't want to mention the subject. I talk to people, and after 2 minutes, I say, okay, end of discussion. You're right. So I hope I give a good background where I'm coming from. I'm very passionate about this. So all I'm trying on my blog is to hopefully bring some sanity into the discussion. Like, guys, take it easy. We do all kinds of reasoning. Statistical reasoning is one of them. We do default reasoning. We do analogical reasoning. Our mind cannot be explained by Bayes' theorem and backpropagation. Things I can teach in half an hour. Please, and all those philosophers and all those brilliant logicians that worked for centuries on this problem cannot be idiots. You, Mr. Young guy who just took 2 courses and you know TensorFlow and PyTorch, they're not idiots. Maybe you are. So that's it.
Yeah, I have a lot of sympathy, just FYI, for those views. I think this is what Max Planck got to with his kind of statement that's often paraphrased as science advances one funeral at a time. There are these very real human sociological and psychological kind of issues that just flat out get in the way of scientific progress because people start to associate their personal identity with whatever they're working on. And then it becomes essentially a religion, almost a process of faith, if you will.
Actually, he was quoted by Jeff Hinton, and I think in AAAI 18 or something. And I give credit to Hinton. He said, the next thing that's going to be cool is someone who's going to tell me everything you did is rubbish. Come on, guys, take it easy. And he quoted Max Planck,
And Thomas Kuhn quoted him as well in his book. I think it's The Structure of Scientific Revolutions. It kind of really lays out this phenomenon that we see repeated time and time again.
Yeah, it's just that this time around, I've never seen it like this. Those psychological and social and personal issues have always been part of science. Russell and Frege used to criticize each other in the press. It was always, I know the truth. And so we always had that, but not to the extent where I think what happened now is big tech took over and took over in an unhealthy way. I have an article about that because apparently the paradigm suits them. Big data, guess who has big data? The
big
cloud,
compute? Who has big compute?
The cloud, guess who owns it? So it was a beautiful paradigm. Now NVIDIA is talking about AI.
Yeah.
You guys do
custom hardware. Who has that? We do.
right. So many things happened, but it's really unhealthy. I have a friend of mine, his son I'm that old. His son wants to do grad studies in AI. And he said he couldn't find an advisor that would take him because he doesn't want to do deep learning. He loves deep learning. Actually, he toys with it, but he wants to do AI with a different paradigm, and he can't because all the funding, all the conferences, they're all Google, they're all Facebook. If you don't do deep learning, screw you. And now even in government funding, if your research doesn't have deep learning, every other word, no money. So that's not good. That's not good. So
I'm curious, are you running, because you're in the PhD student world today, right? What are you running into?
I was the first one here to do deep learning. And then you spoke to other PhD students like, oh, what do you do? Like, yeah, I'm trying to get into deep learning. They're like, oh, my professor doesn't allow that. They would be like, you'd have this feeling, this distributed feeling that it was coming, it's coming. Like we see it in other places and so on. But most of the professors were actually like, nah, that's rubbish. I can't prove anything about it and so on. And now, as you say, it's almost the opposite. You say, I want to do something else and it's wait. So what neural network do you solve the problem with? That's almost. So I had a question with respect to BERTology and your criticisms of all of this. And just to clarify, I understood that by BERTology, you don't only mean like the latest iteration of statistical NLP. I guess you would say the same thing about LSTMs before that and so on. The approach of statistical processing. Do you think it's getting worse in kind of a continuous manner, or is it really like we do this or we do the other? What's your...
Yes, that's a good point. Actually, I start my article saying data-driven, statistical. So I lump all of those together. Basically, probably the best word for that is empirical methods, right? The methods where you're trying to figure out language by processing the data, essentially. Trying to figure out how long a language works by looking at the observation, which is text, right? So all of these approaches, they include statistical NLP, they include. So, but because it's, I actually, BERTology is not mine. I found it in a paper and I just loved it because you have BERT and you have BERTA and you have Alberta and you have, so basically you have BERTology and the GPT-1, GPT-2, GPT-3, and I expect GPT-20, 20 years from now, it will understand a little bit more than my 3-year-old, but hey, it will go on. But so all of that for me is BERTology, right? It's empirical methods. And my problem is, I have to actually mention this. I am not a critic of deep learning per se, not at all. Actually, in so many problems, not only is it a good technology, it's the only technology. So let me qualify what I'm saying. Deep learning and similar approaches are really pattern recognition technologies, right? And pattern recognition, actually, I'm working on an engine, NLU engine. At the bottom, it's vectors. It's vectors because you need to ground your semantics in something. Unlike, I have a problem with both camps these years. Unlike symbolic approaches where a word is defined by words, like, okay, there's the grounding problem. Like, where does this get its meaning from? This is where word embeddings were brilliant. It gets its meaning, guess from where? From how we use it. Ooh, wow, that was huge. My problem is, at the highest level, you do all kinds of reasoning, man, just to resolve references, just to resolve quantifier scope. So monkeys do pattern recognition, but they can't do quantifier scope resolution. So we're not as intelligent as just elephants. The ceiling of our technology is pattern recognition. But are we aiming to create an AI as smart as a rat? They do amazing pattern recognition. And that's the ceiling of deep learning. I can sign in any color ink you want on that. The ceiling of deep learning, whatever you want to call it, and deep or shallow or wide or whatever, learning from data has a ceiling. It's the intelligence of animals, because they do pattern recognition actually better than the best neural network that is out there. An eagle sees from 2 miles away. So my problem is applying it to language. So vision, for example, is all pattern recognition. God, that's what it is. Speech, anything that has to do with finding patterns in data. Beautiful. Go ahead.
But that was one thing I wanted to ask you about, because you've asserted in several of your talks that you think that vision is pattern recognition, but language isn't. And I would dispute that, because I think that there is a rich ontological structure, if you like, in the vision world as well. And you have to do spatial reasoning just as you might with language.
Right.
But just before we get to that, though, I wanted...
No, but if you may, just,
okay.
Vision is not image and scene analysis or scene understanding. Even in that domain, if you want to go that far, you're going to go beyond deep learning and do reasoning. Just to be, I'm saying image recognition. In other words, recognizing that this is not a cat, this is a horse. I haven't done any interpretation of the image. Once you get there, deep learning, of course, is not enough. Right.
I think some deep learning practitioners would disagree with you and think that we could have sophisticated inductive priors, or yeah.
Actually, I have a challenge also in one of my posts. No one has met it yet. To the deep learning community, I say, let's do a data sample of images that I would like you to differentiate between. For example, if you can get to a point where you can differentiate between a mall and a university campus, both have the same ontological concepts: people, trees, buildings, blah blah blah. The information you need to realize this is not a campus, this is a mall, is not in the data.
You're touching all the points that I want to get to. This is super interesting. Right. So just before we get there, one step back, I think a good way of framing your belief is that you think natural language is a formal language. And what that means is that it can be systematically explained and it's not ambiguous in any way. And that's very much the Chomsky school of thought as well.
I'm always lumped with Chomsky. I don't know why Chomsky represented everybody else. He became the complement of me. So if it's not, then it's Chomsky. The complement, everything else. No, Chomsky belongs to a school at a high level. Yes, we are in the same paradigm. Yeah. But if you go down the ontology, I'm not a Chomskyan at all, actually. I come from the Frege, Russell, Fred Sommers, the metaphysical, the innate, that we have an innate ontological structure, that there's no time to learn language. It can't be learned. There's no way. Look at kids, how they speak. So I come from that school. I share with Chomsky a few things. Yes, that language is an innate module. There's no way we learn it. There's a lot of proof. We never told our kids, if you have beautiful and red in the sentence, you put beautiful before red. But I'm not Chomskyan, but I got your point.
So the reason Chomsky assimilated everyone else is because he stepped into the conspiracy theory, world order, political kind of spectrum, and then therefore, if you're not a Chomskyist, it's because you're trying to hide the fact that you're part of some conspiracy. So
actually, ironically enough, on that part, I'm with him.
Anyway. The thing is, you said something really interesting, because you gave the example of the mall, and in a minute, I'm going to get you to explain the difference between logical and ontological concepts. But you said something very instructive, which is that the information about the mall is not in the pixels. And this actually generalizes to your argument about language, because you think the same thing. But now, in one of your YouTube presentations, you gave an example of about 3 years ago of a picture of a woman. It was a family, it was a mother, and there was also a picture of a student and a female teacher. And you said that it's reasonably straightforward to figure out that there's a woman in the image, but what you call the logical concepts, like the fact that she's a mother and it's a student, you said that's beyond the realms of deep learning. But I put the same image into the Google Vision classifier, and it said that it was a mother. In the student and teacher example as well, it said that it was a student and teacher. It's a similar concept with intelligence, that every time we increase on our benchmarks and we do something that we couldn't do last week, there's always always a chorus of people that say, oh, that's not really intelligence. The goalposts keep moving all the time. And you said yourself, because you cited an example that you think intelligence is not about needing millions of examples. Francois Chollet says the same. We need to be more efficient.
Right. That's a good point, actually. You make a good point. But I'm not one of those naysayers every time. No, I'm a true believer in science, and I'm a true believer of things can progress, and you still probably, I don't know enough about deep learning. I still say that up to now. But so I'm not one of those, no. Intelligence happens one battle at a time, because that's how we're intelligent. I'm a materialist scientist. We have atoms in the end, and they create somehow intelligence. If it did happen, I don't know how many you tried, but I can give you a setting where no image recognition will get it, not because I tried it and it failed, or I tried it and it worked. No, theoretically, there's information that's not in the data itself. If everything is in the data, then actually we would have a completely different science. There are models inside. There are models like force is mass times acceleration. Okay, you can try it on few examples and you say, oh, it works. F is m times a on few observations. But until you figure out that for all, it's not about these few examples that I tried, you don't have a model.
Can I make this a bit more symbolic just for the moment? Because I just want to set up a context for the rest of the conversation. Otherwise, I'm going to be personally confused. You made an argument, I think it was proof number 1, which kind of said it was this argument about learning is compression. Right. And therefore, since natural language understanding is about decoding and not compression, it's not learnable. I think we can define natural language understanding as a relation that has 3 parts of the ordered set, which is the utterances and semantic structures that are associated with that utterance. And this is the data that you're saying we essentially don't have, which is the kind of semantic structure that we build from the utterance, and then a probability associated with that.
No, we do send a lot of information. If we don't send anything, then I'm going to say, speak up. What do you want to tell me? No, we do send quite a bit, but amazingly, through a couple of 100,000 years of evolution, we found out the optimal amount of information I need to send, and we kept out things that I don't need to send because I know.
I understood that. So I'm asking, right. Is this a fair structuring mathematically of what natural language understanding is? A relation between utterances, semantic structures, and a probability.
It's missing one thing, K, or call it BK, the background knowledge that
prior knowledge.
Call it prior knowledge, and it's the knowledge I have, and I am certain that you have.
Common knowledge.
We call it common for a good reason, because it is common. But this part is essential because you can study how big is that part compared to the others. So in other words, how much is innate? How much do I know you know about the physical world that if you never taught a kid that if you let go of the mug, it's going to fall down. We come with a lot of common sense, not just in language. But actually,
no, I agree with you. It's even things that are encoded, genetically, right? That's been there from evolution. But just for the sake of argument, I'm just saying, suppose that we could codify all that in some language, whatever it is. The utterances are in English, S is in semantic graphs, K is in symbolic logic of some kind, second order logic, whatever. That corpus of knowledge, I would argue, is compressible and then therefore learnable. Where am I going wrong?
You're going down a few places. Let me, in one place, the word compressible. When the amount of information we need, let me give you just a simple example. I think if it is compressible, then the background knowledge we have has redundancies, and it doesn't. Let me give you an example, the adjective ordering restriction. It's natural for us to say, I bought a beautiful red car. We don't say, and this is in all languages, we don't say, I bought a red, beautiful car. Even kids, they don't know why. It just comes out this way.
Yeah, and this is you arguing that we have an innate ontological structure.
We have an innate ontological structure, how type checking happens in type programming languages. We actually do type checking. And when the types have a mismatch, we do type unification. And that's how we discover the missing text. I don't want to go into my engine now, but there is a way to uncover what you didn't say. There, like the corner table wants another beer. Want and wants a beer expects a human. You found a table. So you do unification and you figure out what is the salient relationship between person and table, and you discover what is meant is the person sitting at the table wants it. So there are types that are in your type checking. Basically, your type checking in language, it's like a formal language to me, is about saying, let me make sense out of what was said. And after you try to make sense out of what was said, you discover the stuff that wasn't said, so that to make it make sense.
Okay.
Now, my point here is the K is not compressible at all. We don't have redundancies in our ontological system.
So you would take issue with step number 2, right? That NLU is not compressible. I'm agnostic on that point because since we don't actually have this, nobody has sat down and codified human knowledge and the semantic structures and utterances. I don't know. Maybe it's compressible, maybe it's not. Just for the sake of argument, let's suppose that it was compressible and we did have this giant corpus and we could learn it with a neural network. That's all possible, but I think the stronger argument that you make is actually argument 3 in the paper, which is even if we could do that, it would be a atrociously inefficient way of learning it. That a neural network that would need to capture all the K, if you will, by inferring some function, some relation here, I think is just not the right mathematical structure to do that in. It's probably a combination of neural networks plus expert systems plus some other stuff that we haven't thought of yet.
Actually, that brings up a great point. I have a friend of mine who worked with Judea Pearl, who doesn't need introduction. And he worked on belief networks and Bayesian networks. And he's now a professor at UCLA. So he comes from somewhere in the middle, if you want. And he was talking exactly about the computational plausibility of a paradigm. Doesn't have to be only, it has to be psychologically plausible, cognitively plausible, and computationally plausible. Otherwise, something is wrong, right? That should be part of your judging something. So if you have zero knowledge and you're trying just to look for a needle in a haystack, you probably could find it, right? But then it's the theory of computation here kicks in, and it's if you give me an infinite amount of time and an infinite amount of memory, I can compute anything. Yes, but I think what we call intelligence is about not needing that infinite amount of time. Is finding it in a microsecond. Somehow, if you look at the mechanics of reference resolution, my God, 4-year-olds, I was working on this algorithm 20 years ago, and I said, holy crap, a kid goes through all of that shit to resolve E, and they have the answer before you. It's in like almost zero time. So intelligence is not about give me everything and don't worry, one day. Yeah, if I memorize everything, then I have the answer for everything. And it's a hash table where I have this pattern and I have the answer for it. But is that intelligence? I doubt it. Look at kids. Look at how we do things. So he was working on models where he showed if you want to do some induction without any prior knowledge, the computational complexity, and he was looking at simple problems, were beyond even the hardware we have now. If you feed it a couple of rules, couple of don't do this, and a couple of restrictions. This is like optimization with some constraints. Give it a couple of constraints, and all of a sudden it goes to linear and even log.
But just quickly on that, though, because Cholet said that, I don't know if you read his measure of intelligence paper, but he thinks that intelligence is normalized by priors and experience. So to a certain extent, he would argue that if you already encode all the knowledge into a system, then it's not intelligent anymore. It's actually the information conversion ratio.
Yeah, I probably also disagree a bit because then it depends what you call intelligence, right? If you...
He's just defining learning at that point, like intelligent learning, not really
and
the state of being intelligent.
May I shortly summarize a bit what I understand from this? It's that Your argument is that when we transmit information with language, what we do is we take the utterance that comes in and we apply a set of rules, and like a grammar, a formal language, we deconstruct it into its meaning, let's say. And technically, theoretically, deep learning could figure all of this out if given enough data, but it's so computationally heavy, it makes no sense to do that, and it's not possible. So there must be these kind of rules in the background. And since no one ever tells a kid these rules, the argument is that they come pre-built in to you.
Yes, except the stuff that we do is minimal. Even if I figured, and this is where the rule-based traditional logic symbolic went wrong, by the way. They had complicated systems and complicated rules, and they tried to model intention by modalities and possible word semantics and blah, blah, blah. And it was all Greek for nothing, because what's missing, ironically enough, not the rules inside, but the data. Look, there's data that we process, and the utterance is data. But there's data that's missing. Okay, I call it information. It's data. It's that ontological structure, which is data, not rules. It's actually passive information. It's not functions. It's not rules. It's not procedures. It's data that constrain the word in such ways that it will tell me this utterance could mean 2 million things, but because of your type constraints inside, that's what it means, man. That's it. So what's missing is not rules. Actually, we apply now rules, and we do parsing, we do semantic analysis, blah, blah, blah. Even if you figure 100% accurately the semantic structure of what was said, it's not enough. That's what goes into the mind, and the mind applies now the innate knowledge, that ontological structure. Tim, if you want to discuss the difference between logical and ontological concepts, it will make it probably clear where I'm coming from.
I think you said the nearest term to an ontological concept is what logicians and mathematicians have called natural kinds. So they're concepts that exist and concepts that humans have made or come up with. Whereas,
exactly.
Yeah.
And I think that term came first from Quine. Quine was the first to use the word natural kind. In other words, there are trees. We did not make the concept tree. We did not make the concept mountain. We saw a mountain and we gave it a label, essentially.
Yeah.
We said, let's call it a mountain in English. But there are concepts we made up. There is no leader in the world. We made a concept called leader. And so it's a logical concept because it satisfies certain conditions. And
yeah.
But how do you differentiate the two? It seems it's an arbitrary differentiation, whereas I would argue all of these concepts are just defined in terms of usefulness to human existence. A mountain is a mountain because it's in the way, and a leader is a leader because my society organizes itself.
Yeah. I'm not putting an interpretation on different concepts. I'm being more formalist than that. And it's not ad hoc at all. Maybe we should privately discuss the system I'm working on. It's not ad hoc at all. Just on this point, a leader, if it can be reduced further to ontological concepts, things in the word, then it's still a logical concept. It's decomposable. A tree is a tree, and if I chop it in half, it's not a tree anymore. It's a tree. Okay, let me put it this way.
If I chop the leader in half, it's not a leader anymore.
And that doesn't apply to a leader because a leader is not an ontological concept. Okay, here's the thing. A leader is someone that does something. So I said in my post about vision, and you can't go beyond, you need to go beyond the data. A teacher, for example. Teacher did not, there was no teacher if there was no teaching exists. And teaching is an ontological concept, like a tree that I can observe. So we call that thing that's happening teaching, and then we call the agent of that activity a teacher. Otherwise, there is no teacher. So look, so a teacher is, in language, is common noun, like apple, right? Both common nouns, but ontologically, they're completely different. And this is where logic screwed up. In logic, both of them are predicates. So you have a predicate called 3x, it's true if x is a 3. And you have a predicate called leader x, and it's true if it's, no, they screwed up. Predicates are not types. You need to test if someone is a leader. You don't need a test. You just have to look to know if something is a tree. The difference is huge.
So could I make the assertion then that you're strongly advocating for the need for some kind of a type hierarchy? And this is one of the things that you say with word embeddings, for example, you use the word analogies, and you say, if only we knew that suitcases and bags were the same type. But in the 1980s, people advocated for this. They said, if only we had bigger knowledge graphs, then eventually we would have artificial general intelligence. But what I love about word embeddings is that they have this kind of continuous geometric notion. So rather than being atomic, you could actually interpolate between a mountain and a tree. And I think there's something magic about that.
Look, word embeddings, as I already said, are a genius invention. If for nothing, they converted words into things I can compute with. That alone is a huge scientific advance. I can now compute with words. So you don't have to sell me on the brilliance of word embeddings, right? Because people appreciate different things than I do. I appreciate the fact that I converted words into things I can add and subtract. Wow, that's huge, man. So it's a huge advance. But in word embeddings, I also have a post about that. The only thing you can hope for at the end is similarity, one relation.
Is that strictly true, though? Because these word embeddings typically have 300 dimensions if you use the pre-trained ones. So those dimensions could correspond to...
And I use them, but in the end, the only output out of two embeddings is a similarity. Or equality, because equality is a similarity with degree 1. Now, you cannot even do you cannot determine, I tried. I used the glove 300 dimension. I tried to come up with some algorithms that can predict type hierarchy. So for example, here's the thing. You cannot even do subtyping with word embedding. You cannot figure out that a bag and a suitcase are both a container. I tried my best, believe me. I was hoping for...
Are they not clustered together? I don't know whether this is the same thing, but you talked about intension and extension. Right. Surely by only taking the scalar product or the cosine between two vectors, you're doing what you say other people do, which is only looking at the value and the extension.
If I can respond here, though, Tim, the point is, sure, they'll cluster, but they can only cluster around one point in that hyperdimensional space, and therefore they can't cluster around more than one type.
What's missing? Structure. There's power in structure. This was a heading I read when I was 18. There's power in structure. Once you impose a structure, the power you get, the extra knowledge you get. So, for example, by knowing that bags and suitcases and briefcases, blah, 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 are all containers of some sort, a lot by one link. There was a classic paper for Woods. He said, what's in a link? There's a lot in a link. Yeah. The problem with neural nets, there's no structure. Actually, that brings me up to another point. When you compose these tensors in one layer into the next, you lost the structure because the resulting tensor cannot be decomposed now in a decidable way. Its decomposition is infinite.
Could I just challenge that a tiny bit? I know what you're saying. There's not a structure in the sense that these are distributed representations, but actually there are rich manifolds and topologies here. So, for example, you use the corner table is a person who wants a beer. Well, using some topological reasoning, you could actually quite easily find that there's a person involved, surely.
But why not something else?
People frequent bars. Could you not find that out?
Do you mean because there are other objects in the room than the table? There are.
Yeah, I suppose I'm saying that if you have enough examples of bars, you would be able to walk some kind of graph to infer essentially that these type of entities exist in bars.
But then why is it a person? There are many other entities in the bar. There are coats, there are chairs, what I'm trying to say, right? So, what I'm saying is the knowledge is simple. Want expects a person, and a 3-year-old knows that. End of story. Otherwise, look, we go back to if I see all different combinations forever, maybe I can come up with this, but I don't think that's what we do. Ironically enough, the deep learning people come from biological plausibility inspired by the brain, although that's not how the neural network, but then they forget every other plausibility. Like, why are you, I mean, it's not even biologically plausible or cognitively plausible. If we want to learn these things from finding all the combinations, we would not speak until we're 45, just to do quantifier scope. My kid has to see to, I went through an example, that trophy example. If you want to figure out all the examples to, not all of them, even go by the rule of thumb, how many examples you need to learn. We have a rule of thumb. You just go by that and do variations on the trophy, because the trophy could be a phone, could be a laptop, blah, 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 right?
So we're back to the computational feasibility versus an in principle kind of question. And I agree with you on the feasibility.
When people talk about understanding language in this kind of sense, okay, they pose these kind of questions. What does this pronoun refer to? And what object is missing here at this table, or something like this, where what I see with statistical learning, let's say something really simple. A language model is simply made to reproduce text that it sees often. So nowhere in all of Wikipedia and in all the English novels do two people converse about the pronoun in the sentence that came before the sentence, right? It's never in a novel. It's like, and Frank entered the door. And then Mary said to Frank, what did the in the last sentence of this very novel refer to? That never happened. But
actually, you're making my point that the information needed is not in the data.
Not exactly, because what I feel is people then try to ask these neural network these kinds of questions that human would ask to each other. What does this pronoun refer to?
But that's not where I'm coming from. I'm coming from, this is real language use. And if you want to ask a database a question, you better resolve scopes and you better interpret the pronouns properly. Wrong result. And the boss is going to say, and my boss is going to say, screw your system. It's giving me the wrong answer. I'm being very, I'm being very practical. Yeah. If you want to ignore them, one way to solve a problem is to ignore that it exists. All I'm saying is,
practical, a bit the point to the end would be something like, let's test these neural networks by the way that we feed into them. So my hypothesis would be, I accept that the neural network understands the language if it can do something useful with it. So if I enter the corner table wants a beer, and then I ask it to continue the text, and the next sentence is, all right, let's get the guy one, or all right, let's get the couple another set of glasses, then to me that means the neural network understands that there is a person. Whether or not internally does this whole logic reasoning is a different question.
Okay, look, yeah, maybe. Don't try that example. I tried simpler ones, and you don't want to see the results. But look, maybe I'm not making my point sharply. There are things in language that require information that is obviously not in the data. That's one. I can
it's this S and K that I have here. It's the semantic structures and the common knowledge. And I think what you're talking about is what Walid calls NLP, natural language processing. Fine. You can get some text, generate new text or whatever, but if the data set's missing this S and K, it's hopeless that any BERTology can learn it. And secondly, even if we provided it with S and maybe some parts of K, is it even computationally feasible that it can, learn all of K?
It's a lot like reinforcement learning in that sense, a bit. Like it's if we were to just let a reinforcement learning algorithm go on very hard problems, we would a bit make the same argument. All it sees is the input and the reward, and it's supposed to figure out all of how the world works just from that. It seems like a bit the same.
Yeah, except there you're just building a simulator that incorporates S and K. One way or another, you have to have S and K.
Yeah, not necessarily.
Right? If you're doing something simple like Q learning, you're just building a neural network that implicitly does this. So my question would be, all right, if we know that these structures and this common knowledge is missing from, let's say, statistical methods today, is there still a place for these statistical methods? What if someone were to come to you and say, I'm going to build a system that doesn't have these rules built in, but that has a module that can generate rules like this on the fly. And maybe that's how children learn. They're rapidly generating those rules.
And now you're getting into something I'm working on. But before, we keep saying rules. It's like Chomsky. The other is rules. And the other, no, they're not rules. What we have that's missing are not rules. Ironically, they are data, but different kinds of data. It's the data we don't say. So it's like data plus data will do the trick. We're trying to do it with one piece of data, which is the text, not the data that we have in our head. So it's not rules. In the end, actually, neural networks are rule-based. There's a paper that proves everything is a rule, like Kant used to say. There's a rule behind everything. Otherwise, the world will not survive one day. But what's missing are not rules. They are the other data that we have, that we share. And that's why we don't say in the text, because we know we have. So if I want to follow Shannon's efficiency for communication, I leave it out because I know the receiver has that information. So it's data, actually.
Just a quote, because I know you're referring to this quote, which is everything in nature, in the inanimate as well as the animate world, happens according to some rules, although we don't always know them. But you seem to be advocating then that you do still believe in the data-driven approach, but you think we should have some kind of augmentation to fill in the gaps.
That's it. Bingo. That's where I'm coming from.
But the thing is, there are loads of people in the community doing this already. Because a lot of people would argue that the fundamental problem in statistical learning isn't the missing information problem, it's the sample efficiency problem and the lack of generalization and extrapolation.
But that's where they're wrong. They can never get to that point without admitting what the problem with the empirical methods is. They are religious about symbols and admitting there are symbolic structures. Let's call them whatever you want. They don't want to admit one symbol in the system. I can learn everything. Yann lecun had a paper, which I'm sure he's ashamed of now. He put on the archive that you can learn language from characters all the way up. Come on, man. Come on. Immanuel Kant was not stupid. You're not smarter than him. There's a limit to how far you can go with your extremism. They don't want to admit one symbol. It's all neural firing. They have the inside of the brain in their sleep. Like it's all firing. And wait a minute. Who told? If that was the case, the difference between our brain and the chimpanzee is what? Is negligible. Yet a chimpanzee will take 2 more million years and they will not speak. There's something else besides the firing, my friend. Animal intelligence have been studied a long time ago. The best they can do is association. They cannot do the experiment with the monkey. They put a box that if they stepped on it, they would reach the banana. But they put the box in the corner of the room. The monkey almost went hungry. They didn't do one simple deduction. I need that much height. That has that height, if then else.
At the end of the day, we have a structure of meat up in our head that's based off the same basic biology. And unless we're going to believe in souls or mysticism, at the end of the day, it does just come down to firing of neurons and some very complex temporal pattern. Now, here's the thing. Neural networks as they're framed today, even at the neuron level, are vastly different from what's actually happening in the biological space of the neurons. Like, I'm curious at a structural level. So literally at the neuron level and connectivity level, what do you think are some of the missing features of actual biological neurons at a structural level versus neurons that we use in the sort of neural networks of today? What's missing that enables this advanced behavior? Let me just pose some examples. Is it the nature of the connectivity? Is it the nature of the nonlinear aspects of the neurons? Is it the nature of the temporal aspects, like that neurons can fire over time and basically do computation, iteration?
Local processing.
There is the synchronicity issue, yes, temporal sync. And there was a brilliant scientist years ago, actually he was my external examiner on my PhD, he was at Berkeley, who tried to model variables, if you want, like how do I know in programming if I want to refer to something here? And that was a genius innovation by Frege, the idea of scope I have. So we have scope, and that's like bindings, and that's reference, and we use it in language. You say it, and I know it's pointing. There's like a reference, a pointer actually. So He tried to model that with time, with temporal aspects in neural network. That is amazing work. But I'll get to your answer about what's missing. But I think what's missing is the information we pass. It cannot be all numeric. And who said, now about the human versus animal. I know that, by the way, I'm an atheist, proud atheist, a radical atheist. So I am a scientist to the bone. Okay. But the difference between us and animals, you actually made my point. We're almost identical biologically. So there's something else, obviously, right? And if you think about it, it's language and thinking. And that was discovered years ago. Thought and language are if and only if you can have thought. So language is not just NLP. That's the point I tried to make. Language is, I think we should find another acronym. I came up with one yesterday. H, little u, T, big U, HUTU. Human thought understanding. We're not, this is about thinking. We're trying to interpret the thought behind what you coded for me in English or Chinese. The difference between us and animals is at some point in the evolution, something happened biologically, no spirit, no nothing, that triggered the creation of some module. And if you look at the history of that, I really tried to read a lot about it. It happened at the same time when people started creating tools, and they're not stupid anymore. They don't try to move a rock like by bringing 2,000 tribes. They found out the lever, and then so thought and language came together. Something happened biologically, some spark that made us different from other species. And we went, obviously now we can bring an elephant as big as my apartment to its cage, gladly buy a banana. So obviously we're much smarter. We developed something else. Language came with that. What is it inside? I don't know. But your question is, what do I think is missing in neural net is that the information passed from one layer to the other, although that's not exactly how it happens in the brain, I agree. Actually, in the brain, there's no back propagation either. But the information passed cannot be all numeric. Why are we saying the information is just numeric? Who said? In the end, if it's numeric, it's also symbols. So why? The strength of the firing? There's nothing in my mind that says we're not passing. Look, our genetic code is a language. Call it anything. You don't want to call C and G symbols. Call them, I don't know, X and Y. Call them anything. But we pass information. That information cannot all be numeric. This comes to the intentionality we can do with intention. So obviously we pass richer structures than that. Now, if you combine that with the learnability, the power of the neural net is the learnability. If you combine learnability with richer structures, man, you're onto something. But you want to fix it on vectors and numbers? You think you can model the word? We were talking about word embeddings. They cannot do more than similarity. That's their ceiling. But why are you stuck on, I don't want to admit symbols. I don't know how they are manifested inside. So let's agree on calling them something else. But the information passed is much richer than just a weight. It cannot model this cannot model everything. That's all my.
The question I have about explicit knowledge, like we did in the 1980s, is that it became quite brittle and the knowledge graphs just kept growing and growing.
Actually,
if we do play the knowledge game, a lot of people have different ideas of what knowledge is and whether there is such a thing as absolute truth, right? Because in the Enlightenment period, we arrived on the concept of facts.
But Tim, that's why I wanted to interrupt. I know where you're going. And this is really what makes me now even on bad terms with the guys that are still working on that approach, because they're all playing God. Doug Leonard, psych, okay? You don't want to see the debates I had with him. He thinks this is how the word is structured. You go to SOA, he thinks that, and they were all playing games and everybody described their own ontology. And wrong. The structure we have, now I'm going to get into details of what I found, but the structure we have is universal, and thus it cannot be created. It has to be discovered. Anything that can be created in more than one way, by inverse logic, it is not different, thus it has to be discovered. We have to play like archaeologists, discover that damn structure underneath language. All that they're doing is rubbish. They will never scale. McCarthy told them, you will build something that you won't even understand in 5 years. And that's where they are now. I know people that work with them and then add this piece of knowledge, maybe it'll get smarter. And that's rubbish. By the way, Tim, the structure that I found out is a lot smaller and simpler than anybody would have thought.
Which of your papers lays this out?
I stopped publishing on the internal structure after I won an award and solved a big problem, Best Paper Award, because I'm thinking about this commercially now, really. There's it's a small type constraint structure. And look at a 4-year-old. 4-year-old has the knowledge base of Doug Lennon. My God, a 4-year-old can barely walk, but they can speak fluently. The structure they have is much simpler than we think. I don't know why.
Probably has to be.
It is. Actually, the entire ontology is like 2,000 types. Something you can code in one day. What is that structure? And when you have a mismatch in typing in the text, how do you do type unification to discover what was not said? That's the trick. Look, language cannot be that difficult. Proof, 3-year-olds. Okay, yeah. 3-year-olds don't have domain knowledge. They don't have the knowledge base Doug Lennon is trying to build, and he's acting like God. First, we have things, and then we have abstract things. Who told you? How? Now you're asking me, how do you discover that structure? How do you discover what is underneath? You have a theory called language. Reverse engineer it.
Do you allow for the possibility that these types and even the structure that connects the types are themselves represented in a distributed way? Let's say in a vector numerical way.
Exactly. I'll send you a picture. Can I share something? You hit it. There's the data level. I'm not ignoring there's a data level, but there's a lot above.
Tim and Yannick, this is completely in line with the discussions we've been having in the image recognition space of, look, if you just add a little bit of structure, add a little bit of common knowledge, equivariance, invariance, if somehow that was built into this processing, you could be so much more efficient with your degrees of freedom and a lot more successful.
But
because it could do this spatial reasoning.
Against that, it always comes across that the kind of transformations we can think about as humans just don't cut it for the real world, at least in vision. Like people say, it should be translation invariant. Like, really?
Yeah, Yannick, it cuts it very well. That's why we've survived. That's why our species exist. It works really well in the real world.
I know, but vision seems to be harder because language is language, whereas vision, if you take it on a photograph on a camera, you've got this weird spherical manifold, and it's not really a representation of things as they exist in the real world.
I think they're very different. I can't say which one is harder. Is mixed integer optimization harder than continuous? It depends on a lot of factors, right? Nonlinear, is it brittle? How many dimensions, et cetera? So I don't know which is harder, but they're definitely very different.
I think if you go beyond just image recognition into scene analysis, then you will encounter the same problem as language. And that type structure will also help you because you know what constrains what. And so here's the thing. We have data and we have information and we have knowledge. Forget the symbols. I know you don't like symbols, but right. At the bottom level, and remember I was talking about ontological concepts, things like, and they don't have to be physical, by the way, ontological concepts that just are. They happen, or I see them, or whatever, or I experience them. Like I saw someone going like this, we called it dancing, whatever it is. So these are the things, right? And these come from sensory inputs, signals. That's where the neural network will give these things a meaning, these type judgments. It will tell me what a human is. It will tell me what a dancing is. Yeah. Because the neural. So I get these types. That's where I build my ontological structure. Now, these things are type judgments, okay? I walk around like a 4-year-old. I see a human. I see a dancing. Sometimes I might use my dad and say, what is this? And he tells me that's a raven. Okay, whatever. But that's the data level where neural nets are the only, not they are good for it. They're the only alternative because I need to make a pattern and call it something. That's where neural networks are powerful. Then we go to information. Now, these types That's where our structure has this richness. So now I know that articulate is something that, generally speaking, makes sense of a human. And by the way, there's polymorphism here. If imminent event, that means any event type also goes there. So I can say imminent trip, imminent seminar, whatever. And then there's the third level where I start making statements. And so
that's analogous to first order and second order logic, isn't it? At some point, it's like types and then qualification over types, or quantification over types.
It is related to logic, but believe it or not, the final output has nothing to do with the logic.
All I know is that static typing helps programming significantly.
Yannick, don't tell Yannick that. That's
gonna. I got into Python recently and I love it, but I hate that it's not type.
Me too.
Yeah, I think Walid would appreciate that. In my opinion, types are like violence. If they don't solve your problem, it's because you're not using enough of them.
But then you've just externalized what you want to solve into the type system. Then you're essentially just programming in the type system, and the type system itself isn't type checked, right? Like I can build a union of any two types.
Yeah.
So if I have a type system that completely solves my problem, I've just programmed my algorithm in the language of the type system, which itself has no type system. So
No.
We're slightly derailing this.
Yeah. You can make a type system where the type checking, the final representation has to be language agnostic. Otherwise, you're doing something wrong. So if I say John knows that Sophia wants to be famous, the thought underneath that, whether I say it in French or Dutch or German or English or whatever, the thought behind it should be language agnostic. So it's like a knowledge graph, but the trick is how do we go from that to that knowledge graph, which has no predicates whatsoever. It's not there are some primitive relations, like there's the notion of equality. And these relations are really cognitive relations that every human being can relate to. We can all relate to this equals this, or this is a part of this.
Now, are you saying this set was empirically discovered, or this is back to human constructed, this is the way the world is?
No, it was reverse engineered from language itself. Like you want to discover how language works, take it backwards. And this is not entirely my idea. Many people said to understand human communication, we have to reverse engineer language itself. It's the best model of our internal mentalese.
But those were examples from that process, from a reverse engineering, right? Not from an on-high, this is the way I think the world is. Okay.
No, I reduced it to primitive types that would be available. Like anytime your internal representation has subject and object and verb, and I mean, come on. There are languages that don't have that structure. If you cannot reduce your internal representation into language agnostic representation, you're still not there. So I kept pushing it to this raw stuff. And then the types came up and I discovered there's a logical type. That's what I meant by teacher is reducible. Teacher is just an agent. Agent is universally, cognitively universal. I know there's an actor in an activity. That's okay, that's acceptable. So teacher is just an agent in something we see and we call teaching. You have to reduce it all to internal stuff that we all have. Otherwise, you're doing symbolic stuff. So that's why the symbolic camp also doesn't like what I'm doing. So I'm stuck in between. I'm like, guys, you have the data level covered, that where the signals come from, but you guys, everything you have in your system is symbol defined in terms of symbol.
Yeah. Just like Mr. Miyagi said, if you walk the left side of the street, you're okay. If you walk the right side, you're okay. If you walk in the middle, squish, just like grape.
So what goes a bit not against that, but in especially the last few years, we've actually seen, as you say, the opposite trend. And the matter of fact is that as we take out rules from these systems, they get better. We take more and more, and now the best systems we have is just a very agnostic 2400 layers transformer.
Right. My last word on rules is I did the same and the thing got better.
Yeah.
I took rules out. It's not about rules. I rarely have rules in my system. There's structure.
But still, the structure you impose in a 50-layer transformer is so minimal. And as we take out structure, but just make it bigger, it gets better, right?
Yeah, because on that, we're in the blank slate, the Tabarrossa paradigm, and transformers are a super generalization even of fully connected neural networks. And why does such a blank slate paradigm work so well?
Does it work so well? Well,
it does, because this is the thing. There are so many ways we can constrain. We could put priors in to constrain these things, but the most general purpose models work best.
Tim, as far as language and these systems, they're really like UFOs. You hear about them, you never see them. Every time I try one of them, it doesn't know. I don't want to be. It's too early to speak French. There's no. We keep saying they're doing well. Where? Come on.
You're not allowed to use them anymore, Walid. They're not going to give you access. They're not going to give you access to them.
The difference between GPT-3 and GPT-2 is not that great. And if you use what's available, they're a joke. Alan, I tried the AI too even. They're nowhere near anything we call understanding. Come on.
Yeah, but this is it. So this is the example you gave in one of your articles, which is that the premise on entailment, a house is bigger than a chair, hypothesis, chairs fit inside a house, and we're getting an entailment of 45.7%.
Which is a contradiction of 52.1. It's pretty bad. It's not as bad as whatever the other one was, but this still is terrible.
It's pretty bad, although it's not as bad as the one I think.
Actually, Tim, can you stay there and say chairs fit inside a home?
Inside a home?
Yeah, they should get that.
Okay, this will be interesting.
Word embedding will do that. Home and house.
It's quite similar. This was the other question I wanted to ask you, Walid, though, because I think you implied that because there isn't a type system inside in this paradigm of deep learning, that it would think of home and house as being completely separate. I think because there's a statistical interpolation between the word vectors, I think it would infill.
Right. Word embeddings will do the job here. Home and house will be quite similar. But if you say a dwelling, maybe now you're way off. And you're already...
Try something else. Try a mousetrap. See what happens with a mousetrap.
And you're already in the 52% contradiction, for God's sake. This is beyond a 3-year-old. Now, so it likes dwelling.
Just put any two sentences with dwelling...
Matchbox.
Like at the end.
Yeah, I've done that. I've done that. Yeah, and it really actually put...
Okay.
Tim is bigger than a dwelling. Go.
Oh, nice. 44% chance of that.
Come on. So
that's harshly true.
Here is a problem that I have with these kinds of assessment, right? Is that they're very constructed and they don't tell us much about how these models, or do these models understand language? Because naturally, we know this, the best example from this is visual question answering. So you get a picture and then you get a question along with it. And the question would be something like, what's the ground covered with? And I don't have to show you the picture. Like the answer is snow. Like just from language, that's going to be the answer. And I feel a lot of these, like these kind of super glue tasks there are so many shortcuts, and it's not really about how these, what do you think?
That's another problem I have. These glue, and they keep breaking records, and out comes another paper and chop more trees and publish. And these days you have someone has 12 papers in a conference. Like, man, I mean, John McCarthy had 12 papers all his life. So basically it's another table at the end that says, I got 0.01% more accurate than Jim, and that's a paper. So, and these glue tests, if you look at them, actually they were at above 90% accuracy 6 years ago. Isn't it time to say we're perfect? I mean, stop playing this game. You create a data set that suits you well, and you optimize it for your code, and it's a game, right? It's a game. The Winograd Schema challenge is decent. I wrote a paper to improve it further. It depends what you want to test, but for language understanding, all these glue benchmarks are a joke. These are for tech companies to play games with each other, Facebook and Microsoft and Google.
this Winograd Schema challenge. I just looked at this paper describing it, and there were 108 pronoun disambiguation problems and 89 Winograd schemas. And so the pronoun disambiguation, I think that's the one where you gave an example of the trophy fit in the suitcase because it was too big or too small, and you want to resolve.
Yeah. By the way, my opinion is it's a decent test, but it's not enough. But I wrote about that.
Okay, but there's only 108 of them. And of course, it was designed to be Google proof, because at some point you can just go on the internet and search for these things. But that doesn't, this is part of the super glue challenge, isn't it? 108 tests, that just doesn't seem, doesn't seem like a good test to me. No,
on the glue benchmark, again, they created their own set of the Winograd, and they said, if we can do that, we've done the Winograd schema. That's not the point of the Winograd schema. The Winograd schema is open-ended. I give you a sentence, and it has a reference in it, and the reference has at least two choices. So you have to think, make a decision. And so they created their own set, and it's obviously optimized for that. And they say they have 90% What? If you have 90% accuracy, I'd like to buy that system. You've won the Turing Award. It's a joke. It's a joke. I can beat those systems with one example. There's a lot of hype, and it's too. Academia has become, unfortunately, when we used to go to HCI or AAAI, my God, I was afraid to meet anyone because I'm so idiotic about AI. Now they go and they present 15 papers, and like, what the fuck? Albert Einstein didn't publish 15 papers.
I always used to say, the great thing about deep learning is that 15 years ago, you had to have specialized knowledge about vision or language processing. You actually needed to know something about the subdomain. Whereas now, all you need to know is how to build neural networks. You don't need to understand anything at all.
Yeah.
But is that the good or the bad?
It used to be that in data analysis, we thought that garbage in was garbage out. And all that deep learning has changed is that garbage in is garbage out with a high degree of confidence. It's
garbage
like,
in, papers out.
Yeah, it's like you have people that they don't know anything, and they could write a bunch of code. And there's this sort of mathematical passport type psychology that goes around where if it's complicated enough and I put enough math in there, even if it's just trash, nobody can question it now. And if we found some hack that works really well, people go back in time and try and justify it mathematically, even though they didn't have any basis for doing it in the first place. Like batch norm, for example, all the papers written on why it works, why it doesn't work, etc. So I think it's a bad thing in a lot of ways.
A group of people at MIT published a paper where they analyzed something like 2,000 papers. And they said, we have bad news. We could not reproduce any results. Probably they were able to reproduce a small fraction. And they said those that we were able to reproduce, we could have done the same accuracy with good old-fashioned decision trees.
You should go over to Alan NLP and ask it if batch norm works. Do that, like does.
But to be fair, it's easy to complain, and it's easy to complain about a field and so on. And of course, if you put more math in a paper and so on, but it's not the people doing neural networks have zero knowledge of the domain.
When Vaswani introduced this new language model that predicts the next word, you don't need to know anything about language whatsoever. You're just producing the most general blank slate deep learning model to predict the next word.
Sure, but it doesn't mean that they aren't still experts at that. It's to see what exactly you're doing and how you're doing it and the internals. I think you still need a bit of expertise, maybe not in linguistics, but still in like just the processing of language to have a feeling for that. I don't believe that these are absolute newcomers. But
I agree and disagree. Yannick, I agree with you. They must have something else, right? It's not. But I work in the field. I was around ML people, which now means NLP. Like, wait a minute, NLP is not ML, and NLU is not NLP, and it's not ML. Those young kids who put on their LinkedIn ML dash NLP dash AI dash DL dash Internet of, and I work with them on chatbots and Internet of Things, crypto, everything, and
blockchain.
And we used to be afraid to say, I know NLP alone. Language understanding, that's a huge. So anyways, these guys, I talked to them. They're working on chatbots with me. They're doing dialogue system. They have no idea what language is. You know what language for them is? Tokenizing, stemming, it's text.
Yeah.
And if you
stemming still,
and if you mention any name that work in language, they say, huh? They think you're talking about Monica Lewinsky or something.
In your article here, you actually have some technical descriptions of concepts in language, like this one, metonymy.
Right.
If you ask anyone who's got NLP, deep learning on their LinkedIn profile, what that means, no one's going to know the answer.
Forget it. Oh, I'm talking about questions that are much simpler than that. Forgot. It took them a while to know about lexical ambiguity. Oh, words have different meanings, and we call that lexical ambiguity. Okay, that was an achievement. Metonymy is way above this guy. Reference resolution. Why is that a problem? And one cool guy said, we solve reference resolution by actually ignoring pronouns, stop words.
Yeah.
So but the thing is, though, like in vision, the reason why CNNs are now ubiquitous is because they produce features that are better than any handcrafted features. All of these specialists that were super into vision, they basically just got wiped away. So why is language so different?
Okay, let's start from the beginning. No, language is different. Look,
Is it?
Here's the issue with language, and actually it's not just language. If everything is learnable, I can disprove that everything is learnable in less than a minute. If things are learnable, people have different experiences, different observations. That means they could, in theory, learn different things. There are so many, actually, the vast amount of stuff that makes sense in the world, we cannot disagree on. If we disagree on, they call them, well, they have a name for us. They say stupid. So, since there is so much that we cannot disagree on, that stuff has not been learned. Because if it was learned, we would learn it differently. For example, this is basic science. There's common sense in science too, you know? So one thing is, if X is larger than Y and Y is larger than Z, larger obeys the transitive relation. It's not up to you. It's not up to me. It's not up to Dave. It's not up to Elon Musk. Greater than is a transitive relation, and we know it by the age of 2 or 3. If I tell my kid, hey, buddy, can you put the ball in the bag? Papa, it's much bigger. Bigger doesn't fit. End of story. So if you want to, if things are learned, we could learn them differently because we have different experiences. That's not the case. I don't know when scientists forgot common sense. Look at the word. We disagree on very few things. The way the word works physically, logically, chemically is not up to you or to me. There's an agreement. Otherwise, you're called stupid or doesn't know science. There's very little disagreement in the world we live in. Oh, yeah, we disagree on what we think of Donald Trump. But on crucial things, we don't disagree because there are facts in this world. And these facts are undisputable. That means they're not learnable. They're not susceptible to data. I mean, come on. Every computer scientist should read philosophy. Philosophers can teach us a lot. They don't produce anything that makes sense, but at least they tell us you're going the wrong way.
My question from before was, what would your advice be on how should we evaluate language systems? Let's say we're really trying to come up with these kind of NLU systems, not NLP, but NLU systems, language understanding. What would be a good set of principles maybe, or even a test?
I'm writing something on that. Actually, I wrote some of it in a paper that appeared a year ago, but I'm trying to formalize this. Remember the bit about, and that was the gist of our discussion as to what's unique about NLU, in that there's a lot of information we don't convey because I assume you have it. We call it the common background knowledge. The test should be, can you uncover that information? Then you're doing understanding. So the test that I have, the Winograd schema is one example of that because it's very specific to reference resolution. You need to extract text that is not there to resolve the reference. But this phenomena, and Tim was listing those things actually, he was on that screen. There are 10 big problems in language. Computational linguists give them labels like metonymy, lexical ambiguity, metaphor, all these big problems in language. And they're all a manifestation of the missing text. So basically, it's a generalization of the Winograd schema. Can you uncover that the information that is obviously needed to understand this, but it's not explicitly in the text? Then you have an AI system.
You mean I want to have all of this in a knowledge store and I want to link it?
Or account for it somehow. I came up with a way to actually account for it. Now you might, hey, it will open, my God, some people might say this is something that I can also learn from somewhere. I don't know. But you have to account for that, because our goal is what? You need that missing text to figure out what is really being said. Can you find it? What approach you have? Hey.
But would you accept a system that says, I can't link anything, but I can give you 20 sentences that can follow the sentence you give me, and that all make it clear that I use the words in their proper, like that I have properly resolved a reference, or I have properly imputed the missing text. Otherwise, I couldn't continue the text as such. Okay.
That falls under you managed to account for the missing information. But basically, the language understanding problem, the U, and that makes it different from the NLP, is finding that stuff that we take for granted because I know you know it. So that's the real test. A system is thinking if it can uncover what I know I should know to understand this.
So what if there's a particular bar in Australia, and when they say the corner table wants another beer, they are referring to just the corner table as if it was an animate object and had sentience?
Right. It could happen. It could happen, which means want in that environment doesn't expect a type that is person only. It expects types that are more general. Expects anything. That's fine.
Doesn't that mean then that our knowledge graph will just grow? If the knowledge graph is constructed in that relative way, so it means something different in Australia, doesn't that complicate things significantly?
By generalizing on the type, everything becomes different. So basically, if it's not specifically person, it could be entity. And all of a sudden, you generalize it to anything you want. There's power in type systems. Type structures allow more flexibility than we think. So for them, want is not too restrictive to person. Tables can want something. Okay, that's fine.
But in the world of object-oriented programming, we used to have a type inheritance hierarchy as well, and people abused it massively. It produced some of the most horrible code in the world, and that's why we had the concept of interfaces and composability. So did you think that would be a logical extension of what you're suggesting?
Exactly, and I used to argue against multiple inheritance. Every time multiple inheritance, you're doing something wrong. Nothing is two things. Everything is a thing. So look, the ontology I have is actually strictly binary. You're either this or this. You cannot be, you're either a bird or a cow. I mean, and if you're hybrid, then it's a different type altogether. There's no multiple inheritance. Otherwise, you have something wrong, definitely. Yeah, we created interfaces because of multiple inheritance, and people started saying, and you know why they did multiple inheritance? Of the reuse of code. Okay, so I make it a subtype of this so that I can reuse also the functions that are here. But that's called bad software engineering. I used to teach that, and man, you don't subtype just to reuse code. That means your model is wrong, right? So you can do it in another way by containment and delegation. But the point is there's a system underneath language. It's not an accident that we all understand each other. One of the most things that really annoy me when people say that know a little about language, but language is ambiguous. Of course, it's ambiguous. Even but it's but ambiguity can be dealt with. I know that initially I start with something that could mean 20 things, but obviously we don't stop each other on every time we're talking and say, "Hey, wait a minute, what do you mean by that? What do you mean by?" We don't. We understand each other very nicely. And I go to the zoo and I see a 4-year-old girl and I talk with her for 3 hours and I never stop her to say, "What do you mean?" We understand each other. Language is ambiguous in the sense that we compress things and then we try to uncompress them until the picture is clear. So in the beginning, it has many possibilities, but it's not ambiguous in the sense we don't understand each other. No, we do. So even ambiguity has even type ambiguity. At some point, I have a very generic type. All I know is that this is an entity. So if I say Sarah, or not Sarah is a common female name. Let's say Shiva, right? Or Java is a programming language, and an island is a name of someone. I know someone called Java. So if I say Java, up to this point, it's ambiguous. But if I say Java just told me blah, 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 Java is a human. Islands don't say anything. So unless it's metonymy, like the New York Times said blah, 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 and it's not the New York Times, it's editors at the New York Times. But language is more systematic than we think. Look at 3-year-olds. That's all I'm going to say. You can talk with them forever, and they know what you're saying. They don't have specialized knowledge. They can barely open the door, for God's sake. And they don't stop you all the time and say, Dad, what do you mean? What do you mean? They know, and actually they... So language, I believe, what Kant says, everything can be described by some system.
Yeah.
And what Montague trivially then inferred, which is language is a formal language. It's just that we haven't figured out the compiler of that damn language, right? There's a compiler for natural language in our head that compiles natural language, type checking and all. It does everything according to rules we agreed on, obviously, but we haven't figured it out.
So if we did build this global ontology, because I've been in software engineering for about 20 years, and a lot of teams of software engineers really struggle to come up with an entity structure just for a basic trading application. And we're talking about building a global ontology. If such an ontology could exist, because I know you have the concept of ontological types and logical concepts. So how big do you think this would be? And is it one of these things where there would be a kind of fragmentation? So sometimes you would need to split one concept up into several smaller ones just to have the fidelity to capture the knowledge?
No, first of all, size-wise, I told you, you'll be surprised how you can cover all natural languages, not language, because in the end, these are concepts that are underneath all languages. Of course, you might come up with new concepts every now and then. So laptop didn't exist before, but a couple of decades ago, actually, the structure is quite small. The trick is finding out what that structure is and the relationship between these different types. And here's another one that gave me a big hint. I was helped by many brilliant people that I took from each some smart idea, and I found out something. One of them is Jerry Fodor, who said in a footnote, actually, in a book that I'm still trying to understand. He wrote a short book a few years before he died called Concept. The subtitle is Where Cognitive Science Went Wrong. Very heavy stuff, metaphysics. There's computability in it, anywhere from Alan Turing to what's computable and the mind and neural networks. And he's a big critic of that paradigm, by the way. But in a footnote, where he's describing the formal meaning of ontology, not ontology as we use it now, like taxonomy, basically, or the knowledge graphs, RDF. These are ontologies, genuine ontologies, but he's referring to ontology as in what exists, what's out there, and how are they related, the old metaphysical meaning of ontology. And in a footnote, that it's unbelievable how much information it gave me when I put it with something else I read. He says, every concept is locked or owned by a word in the language, otherwise it wouldn't exist. In other words, actually, Yannick asked me before, what's the criteria? How do you know this is logical? This is the criteria in Fodor's footnote. If a concept doesn't own at least one word in the language, it's his, it's its. In other words, if you're not an ontological concept unless you own at least an adjective or a property that's uniquely yours. It was a footnote, man. And then because of all the other stuff I was reading, I was like, holy crap, that's what it is. So in other words, fx, if I know what x is, what type of object x is, because of some word, some unique word. told me X is a human. Done. And so that makes, in the ontology, going back to the science, that makes a laptop and an iPad really ontologically the same, because there's no word that I can uniquely use for. People think when I'm talking about this ontology that I'm talking about all the concepts in the word. No, the rest are instances. So for example, there's no word in English that I can use on a BMW that I cannot use on. We're talking use in the sense that it's sensible to use on, or it makes sense. Not that it's true or false, I don't care. So sensibly, there's no word that I can use sensibly on Hondas and not BMWs, which means all these things, there goes 20,000 concepts. They're really one ontological type car. So it's much smaller than you might think, Tim. You're not building an enterprise data, you know what I'm saying? Data warehouse, where you have to cover every entity and every person. No, you're building ontological types that cover each one of them, 200,000.
Yeah. Well,
so it's really 2,000 times each times 200,000. We're talking about billions, but the ontological types that are needed for language are a lot less than people would think.
So it's actually surprisingly parsimonious by the sounds of it, and a lot of people would be surprised by that. And you've said previously that data-driven mechanisms can only detect and infer and recognize ontological types, but not these logical concepts, which are the majority of objects in human thought. Right. But anyway, just to close out, you've mentioned Jeremy Fodor, and also in your influences, you've listed people like Immanuel Kant and Richard Montague and Jerry Hobbs as well, actually. But if people are interested in seriously learning about natural language understanding, having listened to this conversation, where would you point them to?
Actually, a friend of mine who works at Amazon just asked me to give him a list, because he said, I don't know anything about NLU, obviously. It depends where you want to start. I would start with the cognitive stuff, where what the hell is language and its relation to the mind. And before I get into specific models, and because then you'll find your way. But the relationship between mind and language and thought, there are some great stuff about that. Really tells you that language is a different beast, okay? Language is really about the mind. It's about thoughts. The only reason we came up with language is we were like so frustrated. I want to convey thoughts. So it's about communicating our thoughts. And that was before we had languages like scribbling on rocks and whatever to express ourselves. But then somehow there was some spark that came up with this unbelievable module we call now language. But so language, if you want to get into it as the AI side of language, not the text processing, which is a noble cause and it provides practical applications, and I'm all with that. But if you want to get really into what language is and how it relates to the mind, and thus AI, I would start with language and cognitive science. People like Jerry Fodor, people like George Lakoff, Lakoff had a brilliant idea. He tried to relate language to the physical world, like language has to be embodied, like metaphors. He believes everything was a metaphor. We say we're reaching a dead end, and it's the metaphor, it's the cognitive schema of a path, and we're trying to go somewhere. And we're basing this metaphor on a physical schema of we were going somewhere, but we were reaching a dead end physically. Like all of our language, you can map it metaphorically to stuff. Read that stuff and it tells you language is not just characters. Start with that. Then you can go to specific approaches. Okay, formal semantics versus cognitive linguistics. There are paradigms in this space also. Or Chomsky, but that family is not consistent at all. The Quine beats the crap of Chomsky, beats the crap of, and they're all in the same camp. Believe me, there were battles. Jerry Fodor beats everybody. So that camp, there are so many also approaches and paradigms, and the role of syntax, the role of semantics. Is it all just knowledge? Is it a hybrid? There's so much there, but at least to appreciate that language is it's not accidental that Alan Turing thought of language as the test for intelligence. He didn't choose pattern recognition. He didn't even choose game playing. I mentioned that in my post, because games, as big as they are, they're finite. So if you give me enough compute power, I'll screw you because I'll compute every possibility and I'll have a score for every path. You're dead. So it's a finite.
There are an absolutely humongous number of permutations of board positions. And they did this self-play, yeah? So they were brute force learning, but clearly they didn't even touch, the search space didn't even touch the possible board positions, but they still managed to create a kind of convex hole and statistically interpolate between various different board patterns. And it worked quite well. So why could something similar not work for language?
But actually, if you look at the details of they didn't report what they actually did. They cheated. They used the A-star optimization algorithm on the graph-based optimization, and they used Monte Carlo simulation to simulate so many games, okay? And then in all these games, there were, yes, it was unsupervised in the sense that the system played with itself. And it learned that when I win, these are the things that I should keep. And okay, there's brilliant learning going on here. My point was, the game is finite. It doesn't matter how big the space is. So basically, with enough compute power, we were able to go in depth more than a human. Then, of course, we're going to win. All that happened. Look, there's a nice paper that explains that I can win with you in card game. They have a nice example. Basically, it's all about increasing my probability. So if I look at more possible cases and observations than you, my probability is higher than yours. Then in the end, I'm going to win. It's a very decidable thing. It just happened that we didn't have the compute power. Chess is large enough. Go is like magnitudes. But with enough compute power, I reached a point where my probability of winning now is like 99.1. I actually, in language, that's why these schema tests are good, because here's an example. A teenager shot a policeman and he immediately fell down. Most likely it's the policeman, if you ask everybody, that fell down. X shot Y, falls down. But actually both possibilities are even plausible. Intelligence is about picking out. If there's no multiple plausibility, there's no intelligence going on. If I say John gave Mary the book and he was happy to do so, there's only one possible chance for he in the discourse, and that's John. No intelligence, no thinking needed. That's the extreme.
But just on that, though, I think a lot of people in this camp think of intelligence as being about reasoning and deduction.
It's reason.
But that completely dispatches with learning and generalization. I think in this conception, the knowledge is explicitly captured and doesn't change.
The knowledge here is that both the teenager might have fell down, it could happen, and the policeman, but one is more plausible than the other. There's plausibility, there's possibility, and there's the probability. The probability is bigger than zero, so both could happen. One is more possible than the other, but one is more plausible than the other. And plausibility has to do with the world we live in, common sense.
If I have a language model and the next sentence I give you, that's what I was saying before. Like, I give you the next sentence. One is, and the teenager ran away. The second one is, so the teenager called 911. The third is, and so on, which all point to the fact that this wasn't possible if it was the teenager who fell down. It was actually the police officer. Wouldn't that be, would you accept that as the system has disambiguated? Okay.
It's more than a disambiguate. It understood.
Yeah. Okay.
Right? Actually, the flip side of that I use in this example, a teenager shot a policeman and he immediately ran away. Now, ran away, most likely it's the teenager. You try to run away from being captured, blah, blah, blah. But it could be that the policeman ran away to escape further injuries. I mean, in the world of possibilities, both are possible. In the world we live in, one is more plausible. So if you can capture that anyway, then you're doing understanding. You're reasoning, right? I'm not. Whatever model explains that what we do in language so quickly, right? Now, So far, obviously, and all my work, I don't believe that information is in data. Actually, that's probably the gist of where I'm coming from. I don't believe that information is in the data itself. There's another structure that powers and constrains these degrees of freedom that are all over the place. There's a constraining system inside. Kids show us this. The adjective ordering restriction that we don't have rules for it, we don't teach kids to do it, and it's universal, tells us there's some constraining system specific to language. Yeah.
And that was the example. So Jane was wearing a beautiful red dress, and no one would ever say a red, beautiful dress.
No, and they don't know why. There's a type system doing all that. So there's a lot of evidence that tells us there's something that constrains all these possibilities. It cannot be that we have to see examples. I do the computation, the combinatorics for one of them. It cannot be that a child has to see 40 million examples to resolve a reference. They would not speak before they're like 45. There's some language module, right? Yeah, it gets bootstrapped with few examples. Maybe it comes to life with few examples. But if you think about it with kids, it's all or nothing. At some point, they can't say a meaningful word. And at some point, forget it. It's like those couple of years, the first 2 years or 3, they're trying to discover the common sense word more so than language. And once they got that, the language module is there already, but it needs that understanding of what makes sense. So it's because as soon as they get it, you can't stop them. It's not incremental at all. I had 3 kids and I experimented with them. No, I just observed them to write papers. But once they hit that threshold, once their system is bootstrapped enough, forget it. You can't stop them. So it's not this incremental learning. Come on, no way. Or I guess if you want to, I'm not extremist about any approach. I'm just against the extremist on the other side, believe me. I'm just seeing so much ridiculous stuff being said. And I'm like, that's when I started the blog. And I'm like, guys, everything I'm hearing is rubbish. No, come on. You've never been in this space. You've never been in the language understanding space. Let me show you some phenomena. There's something called intention. They have no clue what I'm talking about. If I say intention, they always have it with a T, not the S. They don't believe that word exists. Actually, Microsoft Word annoys me. It's not even in the Microsoft Word dictionary. I keep adding it to the dictionary. There's an intention with an S. I give you, and in language, it's the norm, not the exception. In language, we refer to objects intentionally, not extensionally. We don't refer to their final value, which is just one attribute. We refer to them intentionally as a concept that has tons of attributes. So if I say person, I say Xanadu, I have an example, and I have it in the post. If I say Xanadu quit graduate school, then immediately a 3-year-old knows Xanadu is a human being. She or he is alive because you can't be dead in graduate school. There's a ton of things now I can write about Xanadu. She's at least, 20. I don't see a 12-year-old regularly in grad school. And just by saying Xanadu quit graduate school, I can write tons of properties, and I can write like a 3-page description of Xanadu.
But even with that, though, knowledge is becoming quite relative, because your inferences there were based on the fact that people in the Western world maybe go to university at a certain age. Could there be a world where, because I suppose where you're going with this is that it all comes down to reasoning under uncertainty given explicit knowledge.
Exactly. And it's all about plausibility. There's no 0 or 1. People think I'm against statistics. I'm not against anything. All I'm saying is it's a very complex process, man. And it's about that. It is all about degrees of belief. So, for example, that's where logicians actually work a lot about possible words, right? So in the world we live in, people don't fly. But in the Superman world, I have to interpret things differently, completely. What makes sense or in a religious community. And I had to do that when I had to go forcefully with my ex to the church. So I used to, and in that world, I had to accept things that don't make sense to me, but in the world of religion, they do make sense. So there's this idea of possible word semantics, and it's you jump from one discourse, one word, we call it universe of discourse, to another, and you do context switching. There are complex models for that, but in the end, in a certain community, in a certain place where we're all sharing the experience that we have, there's usually agreement on that. And that's why we leave it out from the text, because I believe the rest. So language is a complex beast. And the challenge in language understanding is figuring out how to decode what you told me, given what you assume I know.
It's interesting that you use the word discourse, because that's exactly the same word as the French philosophers like Foucault used. Yeah. But anyway, Dr. Walid Saba, it's been an absolute pleasure. It's been an honor, actually. Thank you so much for coming on the show and talking with us this evening.
This was beautiful. This was great. Thank you, guys.
Thank you. This was fun.
This was great. Awesome.